IM1 which is titled Completing the Multiple Representations Web. And the question that we're going to answer today is, gentlemen, can you not talk while I'm talking? Thank you. What is the connection? So question 77, Royal, can you not talk while I'm talking? Thank you. We're looking at question 77, which is titled Writing a Situation. Each representation below represents a different set of data. For each part, brainstorm a situation that could fit the data. Provide enough information in your problem description so that someone else could generate the graph, table, or equation for the data. Be creative. Your situation, bless you, may be selected for a future assessment. All right, so on the left, for A, we've got a graph that is, what's happening in this graph? It's decreasing, right? It's exponential decay. It's crossing the y-axis right here at what number? Looks like 16,000. So what's something that could start with 16,000 and then exponentially decay? Yes. A bank account if you were losing money or spending money. Okay. How about the value of a car? You buy it and then, you drive it, you put more miles on it, it gets a dent, you have to get it fixed, whatever. It's going to decrease in value. All right, so write that down over here in the column for part A. Part B, we've got this equation, 180 in for A and 1.22 in for B. What could that represent? What's something that could start at 180, and then what does 1.22 mean it's going to do? It's going to grow exponentially by 22%, okay? So what's something that could be that? No one knows? What did I put? The value of a classic car. I said could start at $180 if you started fixing it up and you got in a new paint job, you put in a new engine, and it could increase. All right. Part C. Let's see. In 1980, there was 226 million. And then you're going to take that number and you're going to multiply it by what? I think that says 1.02. I think. 1.02?
Yes.
Yeah, I think there's a decimal in there. So it's growing by 1.02, which is roughly 2%. What is something that there's 226 million of? People, like people where? People in the world, people in the U.S., and people are going to keep having babies, and the population is going to grow. Okay, so they want you to write down. They want you to write down those situations and talk about how they're going to decay or how they're going to grow. Okay. Question 78 says, a virus has invaded Letitia's favorite mountain fishing lake. Currently, there are an estimated, 1,800 trout in the lake. And the Fish and Game Department has determined that the rate of fish deaths will be 1/3 of the population per week if left untreated. Okay. So it says to sketch a graph showing how many fish are left in Letitia's favorite lake over several weeks. So the first thing I did was I made a chart. So at week 0, so at the start of this, there are 1,800 fish. And then after each week, there's going to be 1/3 left. So 1/3 of 1,800 is 600. 1/3 of 600 is 200. What is happening to that fish population? Decreasing quite rapidly, right? Exponential decay. I went all the way down to week 1. Can you have less than 1 fish? I mean, you could have 0, but you're not going to definitely have a fraction of a fish. So then I took those numbers and I graphed them over here. So went from 1,800, dropped all the way down to 600, then 200, and then quickly decayed over here. Part B, theoretically, will the trout ever completely disappear from the lake? Use the graph to justify your answer. Theoretically, no, because y equals 0 is going to be the asymptote. It's going to get really, really close to 0, but technically it would never disappear. And you can't fall below 1 because you can't have a fraction of a fish. You're going to have at least 1 fish, but that's how they want you to write it. Okay, top of the next page says, we're going to take, do you still need to see the graph? Yeah. Okay. All right. Question 79, taking the graph to an equation. Suppose the annual fees for attending a public university were $7,000 in 2010, and the annual cost increase is shown in the graph at right. They want us to write an equation that models the situation in the graph, okay? So if you look at the graph, you're going to see that right here at 0, it's how much is tuition? $7,000. So that's your starting amount. Which variable does that go in for? A or B? Goes in for A, okay? Bless you. Then you need to get the B by figuring out what is the increase from year 0 to year 1. So from $7,000 to $7,700. What would I do with those two numbers? Not subtract. We need to divide, okay? So we're going to take the 7,700, divide it by 7,000, punch it in the calculator. The calculator is going to tell you that it's 1.1. That means it's going up by 10%, okay? So we're going to plug in the 7,000 for A, plug in the 1.1 for B, and that's our equation. Then each year we can plug in the number for the year, and it'll tell us the projected annual cost for this increasing cost of attending a public university, okay? Part B, use this model to predict the cost of attending a public university in the first year you would be eligible to enroll. Okay, most of you are freshmen, so we're going to go with freshmen, right? What year is it right now?
2021.
It's 2020, right? So what year will you enroll as a freshman in college?
2016.
If you did a regular 4 years of high school, I mean, some of you may be here 5 or 6, I don't know, hopefully not. Ouch, ouch. So hopefully you're here for only 4 total years, right? And then you enroll your first year as a freshman, and that would be the year 2023. So this starts at the year 2010. How many years would that be? From 2010 to 2023.
Oh, 13.
13. Okay, so I put 14. I must have calculated it for, yeah. Okay, so we're going to use 14, but if you want to use 13, you can. Here's how you're going to plug it into your calculator. You're going to look at the two operations that are happening. There's a multiplying here and there's an exponent here. What would you do first, exponent or multiplying?
Exponent.
Exponent. So we're going to take the 1.1 to the power of 14. Then we're going to multiply it by the 7,000. And you should get $26,582. Whoever's making that noise needs to stop. And 49 cents. Actually, it is 14 because we need to include the year 2000. So I did it right. If you just take 2023 minus 2000, you get 13, but you have to include the year 2000. So that's why it's 14, not 13. It is 14. Question C. What was the cost in 2000, assuming the rate of increase was the same during the time period for 2000 to 2010? So I'm going to use a negative 10 exponent because that's 10 years before 2010. Okay? And again, you can do this in your calculator and make sure you do the exponent first. So you're going to go 1.1, use the caret to the negative 10 power. Then you're going to multiply that by the 7,000. That means it would have only been $2,698.80. Okay. Question D, using the model that what is the calculated cost for 2012? Are you confident about this value and explain? Okay, so we're going to take to the power of 2, multiply it by 1,000, you get 8,470. And you want to know, will the increase always be 10%? So are you it's roughly when businesses or colleges increase their prices, sometimes it's by 10%, but sometimes it's only 5%, sometimes it's 12%, sometimes it's 8%. So are we confident that it's always going to be 10%?
No.
Not necessarily, but it's just an average, okay? All right, E, in 2012, the annual cost was $8,244. Why is this different from your answer in part D? So you have to take the 8,470 and subtract the 8,244. That's a difference of $226. That means that the fees were less than 10%, less than a 10% increase, okay? So that's what I was saying. Sometimes it's exactly 10%, sometimes it's 6%, sometimes it's 11%. It just averages out to 10%, okay? Question 80. Taking the equation to a graph. For each equation below, make a reasonable sketch of the graph without making a table first. Discuss your strategy with your team before you begin. Okay, so we have the equation y equals 5 times 3 to the power of x. What does the 5 represent? Where it's crossing what? The y-axis, right? And then what does the 3 represent? What it's being multiplied by each time, right? So what's 5 times 3? 15. So we automatically jump from 5 to 15. And then the 15 we're going to have to multiply by 3. What's 15 times 3? 45. So our graph is going to start to increase really quickly. So I made mine cross at 5, and then I just showed that it increased quite quickly. Okay? The next one has a y-intercept of 10. So I had it crossing the y-axis at 10, and then the multiplier is 1/2, meaning it's decreasing exponentially, so it's going down. Okay? And part C, it's crossing the y-axis at 1/10, so way, way, way down here, but it's increasing quite rapidly. It's increasing by 5, so it's going to go up exponentially. Okay? I didn't make a chart for any of them. I just used the numbers from the equation, was able to figure out the y-intercept, looked at the b to see if it's increasing or decreasing, and then did a rough sketch of what the graph should look like for the most part. Okay? I'm going to move that up. You'll see it in just a second. Question 81 says, use each of the situations below to complete missing pieces of the web or to practice moving from a situation directly to a specific representation. For each part, decide which representation you will generate from the